Today we are going to learn about using properties of operations with a little help from Wreck-It Ralph. So by mistake, Ralph jumbled up all of the coding expressions for his video games. It originally said 7 plus 8, 3 times 5, and 2 plus 13. So he messed it up and now it says 8 plus 7, 5 times 3, and 13 plus 2. Vanellope came along and said, this is going to cause a glitch. But then Fix-It Felix came out and said, don't worry, I'll fix this. Now, he actually didn't have to fix anything. Because of the commutative property, Ralph didn't wreck anything at all. Huh? Let's analyze what the commutative property actually means. The word commute means to move from one place to another. You may have heard that term when your parents talk about driving to work. Maybe they commute to their job. That means they drive somewhere and then come back. When we talk about math, the word commutative also talks about moving because the commutative property allows numbers in both addition and multiplication expressions to change their order without changing their answers. So let's look at what that means in an example. 7 plus 8 is the same thing as 8 plus 7. Both of those expressions equal 15. 3 times 5 also equals 5 times 3, and again, both also equaling 15. 2 plus 13 is the same thing as 13 plus 2. The order is not changing the answer to these problems. Now, be careful. This does not work for subtraction or multiplication. So Fix-It Felix is going to show us. 4 minus 2 does not equal 2 minus 4. And 10 divided by 5 does not equal 5 divided by 10. Be careful because there is no such thing as the commutative property of subtraction or division, only addition and multiplication. Now we're going to talk about another property called the associative property. In this property, we're going to deal with grouping. Changing the grouping of numbers does not change the answers in multiplication and addition. Analyzing the word a little bit, the word associate means a partner, or if we pronounce it associate, it means joined or connected with. So when you think about this, when you're associating with someone, you're kind of putting yourself in a group. Now with math, that grouping, if we're talking about multiplication and addition, is not going to change your answer. So let's use the characters from Wreck-It Ralph to help us out. We have Cubert, Vanellope, and Sergeant Calhoun. Now they're all friends, but today, Vanellope decided she wants to hang out with Cubert, so I've put them there in parentheses. We're using math symbols to help you out, and we're going to add these addition signs. So what I'm saying is I'm going to first add what's in the parentheses here, Cubert and Vanellope, and then you would add Sergeant Calhoun. Now, let's say tomorrow, Vanellope decides she wants to hang out with Sergeant Calhoun. So we're going to add those two together and then add Cubert. So if we were doing this with math, remember whatever goes in the parentheses gets added first, and then we would add Cubert to that. Because of the associative property, the grouping does not change anything, and these two expressions are equal. So adding Cubert plus Vanellope first, then Sergeant Calhoun is going to equal the same thing as adding Vanellope plus Sergeant Calhoun and then adding Cubert. Let's use some numbers to make this make more sense. So changing the grouping, remember, this only works for addition and multiplication. So I'm going to show you an addition problem using numbers now. If I add 4 plus 3 in parentheses plus 5, it's going to equal 3 plus 5 in parentheses plus 4. Remember, when we have parentheses, we are going to do that first. So on the left side of the equation here, we're going to first add 4 plus 3, which gives us 7. On the right side, the 3 plus 5 gives us 8. Now, if we simplify this further, 7 plus 5 is 12, and 4 plus 8 is also 12. So they still equal the same thing, even though we group them differently. Here's another property for you, the identity property. When we talk about the identity property, it's good to understand that the word identity means who you are, and that doesn't change. So looking at a character here, Fix-It Felix is always going to equal Fix-It Felix. Now talking about math, there are two things that I could do to Fix-It Felix that wouldn't change who he is. The first one would be adding 0. If I added 0 to Fix-It Felix, he would still be Fix-It Felix. He would still equal the same person here. Nothing would change. And that's because of the identity property of addition. And all it states is if you add 0 to any number, it's going to stay the same. Along the same lines, If I multiplied Fix-It Felix by 1, he's still going to be 1 Fix-It Felix, the same person. His identity is not changing, and that's because of the identity property of multiplication. Any number that is multiplied by 1 is going to stay the same. Let's do this with some numbers. 23 plus 0 still equals 23. That's because of the identity property of addition. Any number added to 0 is going to stay the same. Same thing, 23 times 1 is going to stay 23 because of the identity property of multiplication that states any number multiplied by 1 will stay the same. Here is the last property for today, the distributive property. The root word of distributive is distribute, and the word distribute means to give out. So Vanellope is going to help us out with an example. She wants to distribute candy to her class. Whenever you give something to your class, you should always make sure to give it to all the students as long as the teacher says it's okay, but it's only fair. So using this example, here's Vanellope, and we're going to use parentheses to represent her class. She has all of these kids in her class. I don't know their names, but those are the kids in her class. What's important is she's going to give candy to these kids. She needs to make sure that she gives it to all of them. So notice, she's outside of the parentheses here. These guys are all inside the parentheses. Vanellope is going to give candy to everybody inside, not just one. We're going to use this to help us out as a model with real numbers, but just so you understand, inside the parentheses, whatever is inside is all going to receive what is out here. So let's use numbers to help us out. The number 3 on the outside here is going to be distributed to every single number inside the parentheses. Just as a reminder, when you have a number here that's really close, that's touching parentheses, that means it's being multiplied. So that 3 is going to be distributed to every single number inside. One of the biggest mistakes I see is that people forget. They distribute it to the first number and then forget it is going to every single one of these numbers. Pretend like this is the classroom, and 2, 4, and 5, they all want 3. It's not fair to just give candy to one student in the class. We got to give it to everybody. So if I distribute that 3 to each of those numbers, really what we have is this. 3 times 2 plus 3 times 4 plus 3 times 5. And you're going to see that in both situations, we're going to get the same answer. If I look at the first part before I distributed, so this one up here, if I add 2 plus 4 plus 5, you would get 11. And 3 times 11 is 33. On the bottom there, 3 times 2 is 6, 3 times 4 is 12, 3 times 5 is 15. And if I added all of those numbers together, I would also get 33. So you might be asking, why do I need to do this? It may have been easier to do it the way on the top, but it's a very important property for you to understand. And one of the reasons that it can help you is with mental math. If I gave you this problem here, 15 times 24, and told you you could not use a calculator, one way to do this, if I did not have pen and paper, using mental math, would be to kind of use the distributive property backwards. I know that 15 times 24 is the same thing as 15 times 20 plus 4. So then I could distribute that 15 to both of those numbers, like so. And I could do this in my head. I know that 15 times 20 is 300, and 15 times 4 is 60. Then I could add those two numbers together to get 360. And that's how the distributive property can help you with mental math. You did it! With a little help of Ralph, Vanellope, Fix-It Felix, and Sergeant Calhoun, we now know what the commutative property is. As a review, remember that the commutative property is just a fancy way of letting you know that order does not matter. You're still going to get the same answer as long as you're talking about multiplication and addition. You can switch the numbers around as much as you want, and you're still going to get the same sum or product. The associative property means that grouping can change, and the order is going to stay the same, and you're still going to get the same answer. So no matter how you group with parentheses, you're still going to get the same answer, and again, that is dealing with multiplication and addition only. The identity property, remember that in this, the number is going to stay the same. So when we're talking about adding 0 to a number or multiplying a number by 1, those are both identity properties because the initial number is going to stay the same. Your last property, which is the distributive property, The fancy definition is that multiplying a number by the sum of a group of numbers is the same thing as multiplying it by each of its parts. So think about that mental math problem we just did. You can break apart the number and it's still going to equal the same thing if you multiplied it by the whole. All right, I hope you enjoyed this Wreck-It Ralph lesson. Have a great day.